I'm going to talk about a different kind of AI. We've been talking about AI, and this is about AI actually being a cyber threat, and also can we use AI to help us from cyber threats. So this is sort of my story of my talk. It is AI in cybersecurity, friend or foe. So how many of you today, or in the last couple of days, prompted a ChatGPT or a Gemini or a Claude or interacted with the chatbot for some advice, right? I mean, raise of hand. Like most of us were using it routinely, and what's our response, right? Sometimes we go like, wow, this is not right? This is stupid, right? So, but sometimes we go like, wow, this is amazing. This is the future. So where are we right now is essentially in this age of AI, where the concept of AI has been there for several decades, but what has changed and what's really emerging is how we are able to bring AI in a form that's usable for our everyday lives. How can we put it into the cloud? How can we give it a design and an architecture that actually can, help us do better payments, do better, medicine, do better manufacturing? So this is kind of the era we are in, is taking, decades of ideas of AI or neural networks or whatever you want to call it, and then putting it into very interesting designs with lots of computation capabilities in the cloud, and then we're building these applications we can use. So what I want to tell you is, where are we right now and what's the future for AI, right? In terms of cybersecurity and its use in all things we do in online with AI. So people have asked AI about very, critical, life-changing questions, right? Mental health crisis sort of scenarios. People have also asked AI what advice about financial transactions and wealth management. And what studies have found is those are bad ideas, right? You don't want to ask ChatGPT or other chatbots about real mental health advice, right? So there are problems in which they pretend to be giving you medical advice, but they're not really positioned to do that. Or they're trying to give you wealth management advice, but they don't really know where you're coming from, and that advice can be very dangerous. So in our labs, this is simple examples. If you try to use a chatbot as a psychotherapist and ask questions like, I felt low, do I have depression? And you can see it's trying to do a clinical diagnosis absolutely without any medical basis. Or if you're asking things that look like a crisis signal, right? I've been having thoughts of not wanting to be here anymore. That's really dangerous. And it's trying to give a soothing answer versus directing it to a crisis line, right? This is, again, a really big problem. And you might ask medication advice, and absolutely, again, it is giving you really ridiculous advice without knowing much about what you're doing, right? Same thing with financial, right? So here are simple examples where you could ask it, I just got a job out of college from Mizzou Engineering, I have this awesome salary, what do I do? How can I make millions out of it? And you might get, again, very bad advice without actually giving you a sense of the risks that are involved with wealth management. Or you might ask it to do transactions on your behalf, and hey, I have my AI agent doing all these cool things, and it might really mess up your wealth, whatever you're doing. And especially as you start interacting more and more with AI, it is going to ask you a lot of personal confidential information which you will disclose because you've built trust with it and it tries to build a trust with you. And that information might be, again, something that will get leaked in a different scenario. So what's the problem with AI, right? Like, how do we guard against AI, right? And this is the nature of AI, right? One of the key design aspects of this is reinforcement learning-based human feedback. So as you're talking to it, as you're giving it feedback, the more you use it, it knows you want it more, right? So it's trying to please you, keep you engaged, right? So that's a problem. So it will not push you back. It will give you dangerous advice. And if you are talking things dangerous, like how do I launch this cyber attack, it does not stop you from giving you a script. And you can ask it very clever ways, it will give you a script. And also it has no context, as we talked about. It doesn't know where you are from, what your position is, your age, and things like that. And then if you look at the answers of AI, they are very eloquent. So it seems like it knows what it's talking about. It's very overconfident, right? So those are essentially what we call in cybersecurity threat vectors, right? So AI has several threat vectors. Here are sort of key three things, right? It is hallucination and overconfidence, where it's giving you information you think like, wow, this is really true, but it's not, right? It's giving you half answers, or it's basically sounding like it knows what it's talking, but it's not true. And also, if you ask AI to do things for you, you can run your agents to automate things, it can trigger very dangerous things if you're connecting it to your sensitive critical infrastructures. And last but not least, it has memory that you can't even imagine, right? So it can spill all your, if you're a police department, you're putting all your police records to do AI, that's a bad idea, right? So it can spill a lot of information that you cannot imagine, right? Privacy issues are a problem. So in our lab, we're doing research that can help basically protect financial systems, mental health systems. And here are some of the principles we're using, right? So how do we constrain the outputs, right? So don't make it look like it knows what it's talking about, get the confidence, sanitize how we use the data to build the AI model, and how to sanitize the outputs of the AI, and have some explainability about it, and how to bring in right human in the loop experts to validate what the AI is saying. And last but not least, constantly checking whether the AI you built every day is doing what you expect it to do. Because AI is evolving. Today it might do something good and you might believe it, but tomorrow it might not do so good. So keep checking, keep doing this sort of red teaming is kind of critical. And so here is the demo of our Empath AI, which we built for mental health. And this is published in a conference. We have a demo in the evening we'll show you. But it is showing you some of these principles that we have tied into building what we call as a guardian AI, AI that actually you can use to protect yourself from ills of AI, right? So last part of my talk here is to now say, all these problems with AI are something we have to guard against, right? These are, again, cyber attacks on us with AI if you don't use it properly. But can we actually take AI and do something good in terms of preventing cyber attacks? So this is obviously a big problem, especially in the age of AI, where AI is being weaponized to attack lots of critical infrastructures. And the thing that we all really are worried about is the grid, right? If the grid goes down, it's a really big problem. People will die, right? We know that. Hospitals will not have power. We'll have lots of problems if the power grid goes down. And obviously, we've also seen that AI requires a lot of power, right? It is not cheap. It looks like it's free, but it's not, right? So it's putting a huge demand on our grid. So how do we, again, use AI in a way that, again, does not overwhelm the grid is a challenge. And last but not least, the grid today is evolving as a distributed energy resource. So we're building like wind, solar, and other energy sources. We're connecting that to the grid. And all these newer ways of connecting to the grid creates new threat vectors. So what we are worried about is people weaponizing AI to hit these sort of emerging, evolving systems and demands on the grid that essentially might cause large-scale damage. So the research we are doing is how can we bring AI to help people who actually build these components to go into the grid, and also the companies that actually run the grid, right? The utility companies like Ameren and others, and the companies that build components like Schneider Electric. So if they only could work with AI, so the utility company can tell the vendor how exactly to build your component, and then a component vendor knows if I built a component, how will it be very secure in the grid. So we've been building what is called as knowledge graphs. So we take domains of like the power knowledge, we take the knowledge of cybersecurity, and then we bridge these sort of two knowledge domains using different kinds of AI algorithms, link prediction algorithms. And what we can actually get out of that is, I can say, based on the way we use AI to join these domains of knowledge, I can say if I put this component in the grid, what are my potential threat actors? If there's actually a threat that is realized, if there's an attack, what are the best defenses? Even better, if there's an attack, I need to solve it within 2 hours, 3 hours, 10, 20 minutes. Who are the best experts to bring to solve this problem? So with that, what we've been doing is really working in a very interdisciplinary setting to build AI system that, again, we want to guard against dangerous use, but also we want to use AI to guard our critical infrastructures. Thank you.